Alright, so hello everyone. So my project here is I made a vehicle, and I have a project here. So in the first phase, there's a idea and a goals. So my idea is I was making a vehicle where I can control it with a switch and a joystick. So in the second phase, I needed to figure out what materials I wanted. I will show you the materials later. What materials I used. Um, and then I was just really I will show some videos of like how I made the vehicle, and then in the later in the video I will tell what I learned and evaluate. So here is my vehicle. This is the device I made, and if you see here, I have two Leon batteries here. It's one on battery, so this is two Leon batteries. It's a 3.7 volt. So I put them together because I need 5 volts because I experienced that the vehicle it wouldn't like some of the functions wouldn't work, and the LED wouldn't turn on, or it would drive really slow and turn off. So I put two batteries together. I connected them together. I put the plus onto the minus, and I put on one of the batteries, and then the other one I put in the ground, and one on the plus I put straight here in the ESP on the vent port. So I have two 8 bridges here. I have a drawing of an 8 bridge as well. I'll run through right after here. It's my two 8 bridges that connects to the motor that's under here. I have 4 motors. So what I did, I put them in 2 pits. I think it's like a D32 and 33. I put them on 2 pits here. So when I click on the switch, which is connected here on it has to be an analog. This is an analog switch. So it has to be one on analog ports. I think it's like D12. I put it on. And when I click the switch, the vehicle turns off. When I move the y-axis and the x-axis from side to side, the LEDs will go from yellow light to red light to green light, yellow light, green light. And this is the buck converter. That's so I get maximum 5 volts, so it doesn't explode because I have 7 volts. So that's my vehicle. Okay, so I will get to the 8 bridge now. Alright, quickly, I have made here my 8 bridge. This is my 5 volt power supply, or PSU. I call it a power supply. I think it's called a terminal, a 2 terminal, or 1 battery terminal. And it goes here, and it just two. This is how it's drawn by 8 bridge, because you can't draw it directly. So this is 2 diodes. That is where you saw where you put the wire, and then it goes through. And here in the middle we have the motor, and then we have my ground. So I have a H bridge here. All right, so here I will add a extra file. It's a component list. I will add the file in a PDF form. But here I will tell you quick what components you need. So I have, if you can see here, I have two Leon batteries. I have a joystick. I have two 8 bridges. I have an ESP32. I have a buck converter. I have 3 LEDs. I have 4 wheels, and under this 4 motors, and I have this 3D print plate, and I have a breadboard. That's what I've been using of materials. All right, here we go. So I changed my videos a little bit. I was filming as I was putting it together, but now I'll just explain it here because it's very difficult for me to edit, and then the videos are too long. And so okay, so basically, how I made this, I have 4 motors under here. They go through this H bridge. So we have here, you can see that there's a BA and there's a BA, B1, B2. I call them B1 and B2. And A1, A2, that's 2 motors. And we have a ground, a GNG, and a VCA. VCA is the power, that's where it gets the power from. So this is the motors. So you can see here, I have the 2 motors. They go over here and go into the pit 25 and 26. I put this one also on the other one, and I did the same with this one. I put them on 25 and 26, all of them. And then we have the VC. That's the power. That's how it gets the power. This H bridge gets the power. This is the diodes. It will probably be this one, but so where it gets the power, the VCA, it goes over here to I'm pretty confident it goes to the, what we have, the yellow, the purple one. It goes over here, and the one they call it Win. It's called Win. That's the power. It gets power from this one. So what next we have here? We have the joystick. We have the joystick here. All right. So on the joystick, we have 5 pits. We have ground, a 5 volt, a VRX, and a VRY, and a switch. So the switch here, it needs a program. So it needs a pit. So I put over here, if you can see it on the yellow wire, I put it over here on the, D34. So it's on pit D34. Alright? So we have the 5 volt. What do we have here? We have the 5 volt. And this 5 volt, it will goes in the VIN. It goes over here in the VIN again, because this is where it gets the power from the ESP. You can see I have many VINs here. I actually made a bridge over here because you have to wire from one side to another side to use these both sides and connect them together. And the ground GND, it goes in the ground of the ESP, and it's important it's the ground of the ESP, not the minus over here. It won't work. Anything like I think the battery can goes in. The battery it can goes in this ground, but anything that has like a function, it needs to read for program. It needs to read from the program. So this ground. So that's the ESP. But I don't want, this is the first setup. I don't want. Oh, we have the LEDs also. So the LEDs, 1, 2, 3 LEDs. They need a pit each. They need a pit each because they need a program each. So I have them here. I have them here on 12, 13, and 14. There I have my LEDs. And from the LED minus, again, it goes in ground here. If you put it in ground here, it will not work. It has to go in the ground of the ESP. So this ESP, it needs electricity. So for it to get the electricity, I either have to plug in a cable, but that's not wireless, isn't it? So I had to use a battery. And this is 2 Leon batteries with 3.7 volt. So that if I put them together, I put them together here where I put the minus ground of one battery in the plus of the other battery, and then I put a plus, and then I put the plus battery over into this minus, and then I use this one. So I have 2 cables only. I have 2 cables. They are plugged together. But that's too much voltage. So I want to use a buck converter to turn down the voltage. That you do it in this screw. And on the in plus and the in plus and the in minus, I have here. This is where I put my battery. That's why it's the input port, and then it gets the output. So here the electricity goes through the buck converter, and then it goes out here on the output, and then I put the output over here on my ESP and the ground. So electricity comes in here, and it comes out here into the ESP. So, and then I put my 2 wires here, my ground and my plus, on the buck converters plus and minus input ports. And this is how I made the vehicle. And this is actually the entire thing. Alright, so this is my finished car. So it drives here. When I click the switch, it would stop. And if I move the switch here, on the X and Y axis, it will change the light bulb and also turn it off when I click the switch. Alright, so this is the code that I've been using on my vehicle. So I was actually supposed to have 4 LEDs, but I had some problems because my breadboard is broke and I dropped the vehicle a few times, and so I lost some of the pits. But alright, so this is a constant of type integer. So it's a constant type integer with the name LED pin 1, and the value equals 13, so that's the pit number. And then we have here another const, that's the motor. Constant integer motor in, and that's put on a pit 26. And then we have the joystick pins via X, so that's the X axis. It actually stands here. And we have the Y axis on 35, and this is analog. It has to be analog, it can't be digital. But these pins, they want analog and digital, so you can use them. And then we have the switch pin. That's a function for itself. Then we have a constant integer threshold low. So when it, wait a minute. So that's when it goes to this. When it goes to 1000 of the x-axis or something, or y-axis, it will change the LED. So we have another here that's a declared variable. Int current, it's an integer with the name current LED, and the value is 1. So here we have a predefined function that's very popular here in this thing. You have to see it in here. We have a predefined function called setup, and inside it I have put a pin mode. A pin mode, a statement called pin mode, with the expression LLP1 output, which is also predefined expression of the Arduino library. It's actually, this is a lot of predefined expressions and functions. You know, it's difficult to explain about it much more, because it's just you know, like, you call the function, you call the name, or you call the expression, or you call, you know, whatever is predefined in this library that we can't see. So whatever it is, we have a loop here, which is also again the predefined loop, so it's constantly doing it over and over and over. So what it does over and over and over is it reads my input statements, like how I turn the joystick. And then we have a boolean, it's true or false. So it's actually low. I put it here in the comment. It's actually, so when I click the switch pin, it's equal low. It will actually do the if switch state. This is the switch state. If switch state, if this is low, it will stop the motor, because then will lower the electricity to the motor. And here we have another if statement. So if x value is smaller than threshold low, the current LED, the LED, it will switch to this LED, which is the number 1 value 1. Else, if it's high, like the joystick goes up high, it will switch to this LED. And if it goes low, it will switch to this LED. And this is the way I just turns them off. This is just a common, but if the switch is turned down, LED pin is low, here's the switch. So in case, this is defining it first, I would imagine. So switch current LED, in case of the first case, the LED high, it will turn this LEDs off. So this is my code, and down here we have a delay. So if you put this to 0, it would just, you know, if you put it really high, you know, it would turn off, it will repeat itself. This is how many times it repeats itself. You know, so if you put it in 2000, you know, it will do the function because this is one entire function, you know, one entire function, but like a code. It starts at int main, so it will continue to do this over and over and over. If you put it high, you know, it will take 5 minutes before it turns on, and then it will take 5 minutes before it turns off. And that's my code to the vehicle I have. Alright, so what I also try to do is I have here it's a Docs Arduino CC. This is the communication through ESP now, device to device communication. What I try to do is I try to make a debug monitor where I would send for my one device, I would send to another, and I would have a debug console if something went wrong, and I could see if but I didn't make it, so it is what it is. And we have down here the code. This is where, so you print the MAC address and you put in the MAC address. You will put in the MAC address here on this on the center sketch, on the center code. It will send to this MAC address, which is the physical location of the device. And then we have the center address here.
the sender code here, or receiver code. The receiver code, and we see here we have struct. We have struct type defined struct, and the name is a struct message, and it's inside a block code with a character with 32 characters in it. Character A is a list with a 32 in it, and an int B that is an empty variable, and a float that's because there's two decimals in it, so there's like it's 3.2, where this is just a 3, and then there's a boolean that's something that is true or false. We have end of the block code here. So here we call this struct message. We call the first function, or the first we call the function as a struct, and here we're calling it again. And then we use my data. All right, so we have here another function, avoid on data received. This is a predefined function from this library, ESP now.h. And we have a constant unit t, which is also expressions with the operator multiplied with mac, another predefined expression, and all these things, they are located inside this file that you call with the include, so included in your code. So it prints how many bytes it receives. It prints to the terminal or the serial monitor, and it prints the len, and it prints the character, and it prints the mydata.a, which is a predefined expression again. So now we went through the printing. So we have here the void setup, which is also a predefined function. So there's other things to it. Pretty positive. You can find it in this library. But we added this serial begin at a digital input 11. This number. So we have another predefined function here, which is Wi-Fi mode, Wi-Fi expression. This is expression into the parentheses. It's predefined in the library. Here we have an if statement. So if ESP now init is a predefined expression, not equals ESP okay, it will perform this statement, which is zero print error. It will print the error. So if the if statement is not true, that's a boolean. It's a true or false. It will print this one instead. If it's true or not true, because if this is true, it does that. But if it's not true, it will just print that and will do that function, which is probably just sending the data. And this is a loop, so it repeats the process over and over and over. And like you can't see anything inside the loop, like I said, because it's a predefined function. So if you want to see what's inside it, you have to open this one and look for a function called loop. Alright, that's just what I could have done. This is sending data. Alright, so what I also could have done, if I had time also, and because I had to communicate with ESP now, which is a low latency program. ESP now, it sends over Wi-Fi, but it's not direct through a router. But what I could do is I could have used the router, actual router. So what I would do is I would have my real machine here in a virtual environment. I would get my iNet address. I would get a virtual switch or real switch. I would use a real switch, but you can also create a fake switch or virtual switch. And I use the switch MAC address, and I use the Wi-Fi credentials, and I put it in my code, and then the ESP would communicate through the router to another. So I would have like an ESP over here and an ESP here, communicate here, and go through here and go here. So that was just what I could have done in networking. But I had to use the ESP now communication, and I didn't make it. So, but I would explain that also. Alright, so there's this one more thing, like what I could have done. Like this is my school project. So like we've been giving some like this 3D this plate that the vehicle runs on is 3D print. What I also did, I printed a 3D like a robot arm, but I didn't have time to make it. But what I could have done is like I could have put a server motor on it that could make the robot arm move and from right and left and pick up things, but I didn't have time for it. It was really difficult for me. And I also want to add to this. So this is like an actual switch, but what I could have done is I could have my virtual machine, my real machine here, my virtual machine here, a virtual switch here, a virtual router here, a wheel switch and a wheel router. This is for security reasons. So if you want the device on an actual router, like what we've been talking about is ESP now. This is just radio signals. It's not internet. Like Wi-Fi is not internet. It's radio signals. And then you later invented a wireless internet. So you could have put it on an actual router, and I think it could send more data and it would work better. But it is what it is. And I say thank you and goodbye.